Okay, students, we're going to talk about congruence here and go through many examples here. So, first type of congruence we have is SSS, which stands for side, side, side. Okay, now we can see here that side PQ is congruent to ML, segment QR is congruent to LM, and segment PR is congruent to MN. Okay, so if we have three sides of one triangle congruent to three sides of another triangle, then we can say that the two triangles are congruent. Remember, a short definition of congruent is same size and shape. Okay, so it's the exact same size and shape. Again, we go by the markings. Okay, now don't forget by DCAS, the definition is if I can move from a pre-image to an image by any combination of rigid motions or isometries. Remember our four rigid motions. We have reflection, which is one reflection. We have translation and rotation, which are two reflections. Remember, rotation is two reflections over intersecting lines, and translation is two reflections over parallel lines. And finally, we have glide reflection, which is a reflection followed by a translation, or vice versa, translation followed by a reflection. Okay, so here we see that these two triangles are congruent by what's called SSS. Okay, now they may ask you to write a congruence statement. A congruence statement, which you will be doing on assignments and on your test, is when I say some triangle, in this case, triangles, we choose triangle symbol, is congruent to another triangle. Now here's the key: when you write a congruence statement, you must write it in corresponding order. Corresponding means it must go angle to angle, match up the angles. So if we start with angle P over here, okay, notice angle P is between the segments that have a 1 and the 3. 1 hash mark and 3 hash marks. So that one between 1 hash mark and 3 hash marks is angle M on this triangle. And then say I go Q over here. Notice Q is between 1 and 2, and L is between 1 and 2 over here. So I have to put that one second, and then obviously last one would be R and N. Now, you don't have to go in alphabetical order like that. You can choose any order you want, but you do have to match up the corresponding letters properly. So now we talk about writing things properly. So this right here is called a congruence statement. And our justification would be by SSS. Okay, side, side, side. The next step we have is SAS. Okay, SAS, which stands for side, angle, side. Okay, notice we have a side here, an angle, and another side. So the angle must be included between the two sides. Keyword is included between. Okay, so it can't be outside over here. That's not between the two sides. So in other words, just think of it that the two sides that have hash marks on them, where they come together, where they intersect, which is right here at O, that has to be the angle right there for the SAS to work. And there you see SAS right there as well. Okay, so these two triangles are congruent by SAS. And again, write a congruent statement for that one. Let's say we start with O here. Then we're going to start with Z. So triangle O, triangle Z. O matched up with Z. N, if we go N next on the left side, N is the one that's along with the 1 hash mark. So that'd be Y over here. Okay. Y right there. And then last we'd have M and X. And that'd be our congruent statement, and our justification would be by SAS. Okay, so now let's look right here. Here we see an S and an A and an S. So that's SAS. That's good for that one right there. But do we have SAS in the second one here? Notice we have S, S, and the A is on the outside. So that'd be SSA. There is no such thing as an SSA. Remember, they have to be the exact same anyway. They have to be an SAS. So in order for this one to be SAS, it would have had to been right there. Remember, I told you where the two hash mark ones that come together, the 1 and 2, where they intersect, which we have point F, that's the angle it must be in order to be SAS. So this one is not congruent. Okay, let's go to the next page. Okay, here we have SSS again. Okay, I'm not going to write out the congruent statements to save time. We practice that. 13, we have an SAS and we have an SAS. Okay, so that's an SAS one. Remember, they both have to be the same one. Here we have an SSS. Notice they share a common side. That is called reflexive property. You need to learn this because you're going to use this one in proofs a lot. Reflexive property of congruence. So anyway, you don't need a note for this particular part, but you will come across it with proofs coming up with triangles. So SSS on that one. We have SSS in both of them. Here, notice we have SAS in both. SAS. So that would be congruent by SAS. Let's go to the next. The next type we have is AAS, as you see right here. Angle, angle, side. Okay, that's how you have it. Angle, angle, side. Now here's the tricky one. This is the trickiest one of them all. Okay, because the S, the side, must correspond with the angle it's next to it. So notice this one has two arcs and this one has two arcs, and that's the hash mark that's next to it. They have to be next to the same corresponding angle. So for example, here's one that would be false. If say this one wasn't hash marked here, but instead I put the hash mark over here. Oops, let's change it to blue. Okay, if I put the hash mark over there, well, notice it's still an AAS situation, but here, where's the S? The S is next to a single arc, but this S is next to two arcs, so they are not, even though they're both set up as AS, because that hash mark is next to the wrong angle, in this case, that would not be an AAS. So that's the tricky one right there. But back to the original, this is AAS because this hash mark and this hash mark are next to the same corresponding angle that has two arcs there. So that's the key. Don't get caught just quickly looking at AAS. Oh yes, make sure that that corresponding side is next to the corresponding angle as well. All right, here we're determining which they are. So here we have an AAS on this one, and here we have an AAS. Okay, now the question, I'm sorry, that's a tricky one. Is the hash mark on the side next to the corresponding angle? Yes, that's one arc, and that's one arc. So yes, that one is AAS. Notice on this one here, we have SSA. There is no such thing as SSA, so that's nothing. Here we have SSA as well. So we would write not possible. Okay. Next one. Here we have ASA. So angle, side, angle. That's another one that you can have. And here we have angle, side, angle. So these two are congruent. Okay, because they're both ASA. This one over here, we have AAA and AAA. Now, AAA is not a triangle congruence one. AAA, also just called AA, because if two of the A's are the same, then the third ones have to be the same because you're subtracting the same number from 1 to 80. So sometimes they call the AAA similarity or just AA similarity. So if it's AAA, that just proves that the two triangles are similar. They are not necessarily congruent at all. One could be a dilation of the other. Remember, all dilations are similar ones. Okay, next, determine whether we have enough here. Here we have an ASA in this situation here, and here we have an ASA. Okay, and again, we're checking they both have one arc, and they both have two arcs, and they both have two hash marks, the exact same numbers, or hash marks or numbers. Here we have an AAS, and here we have an AAS. We both have AS. Remember, that's the tricky one. Is the S in the right spot? The S is next to the two arcs here. The S is next to the two arcs there, so it is in the right spot. So that is an AAS. Okay. Here, we're determining the same thing. So here we have AAS on this one, and here we have AAS. And their S is next to the right corresponding um, angle of one arc and one arc. So that is true. So they are congruent by AAS. Here we have SAS and SAS. So both of them are SAS, so that works. So they're justified congruent by SAS. Here we have SAS, and the bottom one is also SAS. And again, the same number of hash marks, so that means they correspond to the same number of arcs. So these are congruent by SAS. Here we have SSA. Remember, there is no such thing as SSA. SSA, so not possible. Okay, so here we're completing the congruent statement. I told you about the congruent statement before. We're completing it. So here we're going angle ABC in that order, matches up with, and notice the A is next to the one with the one hash mark. Here's the one hash mark, so that's going to go D. The B has one arc. The F has one arc. C is my other one, so E is my other one here. Okay, here, ABC. A, notice A is between arcs 1 and 2. So which one's between arcs 1 and 2 over here? P. B is between arcs 1 and 3, and Q is between arcs 1 and 3. C is between arcs 2 and 3, and R is between arcs 2 and 3. We got to put them in corresponding order, that's called. Okay. Next, we have ASA here. Okay, so we're matching up FDE. F has one single mark, M has one single mark. D has two arcs, L has two arcs, and therefore it's N for the last one. Okay, those are called congruent statement. Here we have ASA, ASA. So ASA there. Here we have AAS, AAS, and the single hash mark is next to the 2 and the 2. So that AAS does work. Remember, that's the tricky one. Here we have AAS and AAS, and the hash mark is next to the single one and the single one, so that works. So we have AAS there as well. All right, that will do it. There's one more that we haven't talked about yet called HL, and I'll bring that up in another one.